This video will be about soil. Soil is a super important part of our economy. Good soil makes us grow good crops and bad soil doesn't. So we study soil because of the medium for crop production, producer and absorber of gases, which sometimes we forget about, medium for growth or plant growth, home for many organisms, plants, animals, and others. So it's very important in the food chain. It's an essential natural resource. Soil acts as a filter of water and waste, and I know that's hard to understand, but water does act as a filter. Source material for construction, medicine, and art, waste decomposer, and there's a snapshot of the geological, climate, biological, and human history when we look at soil, so we can learn a lot about the past. Soil forming factors, things that form soil. First of all, you have a parent material. Usually this comes from the bedrock. So whatever material, rock material is available is what's going to break down and make our soil. And the two methods of breaking down are chemical weathering and mechanical weathering. Biota are all the living materials that you would find in the soil. Those are going to help form the soil. Topography, which means the lay of the land, how the land is shaped. Is it hilly? Is it wet? Is it a wetland? Is it a depression? Those are all things that are going to help determine the soil. Climate will determine how much the soil breaks down. It'll determine what types of soil you have. Whether your soil be wet, moist, or dry, all of those things. And then time. The first four factors over time. Time to break down, time for weathering, time for erosion. All of those would be factors that will determine how the soil is formed and what soil you form. What is soil? So defining soil, we say dirt. Okay, well, what is dirt? Soil is defined as the relatively loose agglomerate of minerals, organic materials, and organic materials are anything that is living or was living, and the sediments that are found above the bedrock. That's how we would define soil. Characteristics of soil. There's physical characteristics. Is it the texture, so how it feels? Is it rough? Is it smooth? Is it, really clay? There's different types of textures. Consistency, does it stick together? Does it fall apart? And then structure. Different soils will have different structures as far as what the shape of those little particles are, and that will help them stay together, not stay together, hold water, not hold water. Soil compaction. So when we compact soil, you are pushing out any air or any spaces that water could be available in there. So soil compaction is an important part of soil because plants need oxygen. They need that air space in the soil. And if they do not have that air space, then there won't be any space for water, and the roots won't be able to breathe. They need the oxygen. I know we think animals need oxygen, plants need CO2, but plants also need oxygen. Soil moisture, that's a physical characteristic of soil. It needs moisture. Nutrient characteristics would be the soil chemistry. So what do we find in the soil? And these things are determined by the chemical bonding, so the nutrients that would be in there. So that would be any of the elements on the periodic table. Magnesium, calcium, sodium, so all of those minerals. Then if we go on to the pH scale, the pH scale runs from 0 to 14. 7 is neutral, and anything below 7 is considered to be acidic, and anything above 7 would be alkaline or a base. And that has to do with the ions that they provide to the liquids that they are in. Cation exchange capacity. So cations are positive ions, and can they give up those positive ions? Nutrient availability. So what is available for the plants to use? Physical characteristics of soil more detailed. Texture, the mineral components. So is it sand? Is it silt? Is it clay? Is it a mixture? How much sand is it? How much silt is it? How much clay is it? So consistency and structure, how the mineral components are put together. So once those particles are in your soil, how do they go together and do they give it a structure? Bulk density. Density is by definition mass divided by volume. So if there's a lot of soil packed into a small area, it would be very dense soil. And that compaction is going to be pushing out any air pockets or for water and air to be in the soil. Soil moisture. How much moisture is in the soil? Farmers will have this tested so they can know what their soil moisture content is like. Soil texture. It's what the soil feels like, and it depends on the size of the mineral particles in the soil. Sand, silt, and clay are the three major particles that you would find in soil. Sand would be the very large particles, and they would feel gritty. Silt is medium-sized, and it feels soft and silky, kind of like flour. Clay is going to be the smallest particle size, and they feel sticky. Here is a size comparison of those three particles. Sand would be this big in comparison to each other, like a beach ball. Silt would be like a frisbee, and the frisbee is the shape somewhat because that's going to give it that silky smooth feel. And then clay would be the dime size, very small in comparison to each other. The soil texture triangle helps us determine the components of each one in there. So percent clay would be over here on this side of the triangle, percent silt on this side, and then percent sand. And so if you were given the percent of silt and the percent of clay and then the percent of sand, you would draw those three lines from each side of their triangle, 0 to 100 over here for clay, 0 to 100. So if it was 50% silt, 50% clay, and 50% sand, since we're coming from 0 to 100, that would be halfway between, so that'd be 50. All three of those lines would triangulate to this point right here, and the L stands for loam or loamy. Equal parts sand, silt, and clay is called loam soil. So the effects of soil texture. Obviously, we've all heard you don't build a house on sand because it doesn't have a nice structure, and that is because sand is very big particles, and you would feel that because those particles would be very rough. Soils are more cohesive when they have more fine particles, so that would be your clay. Cohesive means that they're attracted to each other. Adhesive is when it is attracted to something different. So like a bandage is an adhesive bandage. It's a Band-Aid, and it's attached to you, your finger, whatever, your skin. Soils are more loose when they have more coarse particles. Different combinations of coarse and fine contents produce different soil textures. Loam is that mixture, and it will be if you have pure loam, it'll be equal parts sand, silt, and clay. But there are sometimes when you have more sand or more silt or more clay, and that's where you'd use the soil texture triangle to determine. Many other inclusions, such as cobbles or boulders, those would be your bigger particles in the soil. Soil consistency. General organization. Hold a moist sample between your thumb and your forefinger and gently squeeze it until it falls apart. This is giving you whether that soil will stay in a ball where those particles will hold together. The soil is classified by the following categories: loose, friable, firm, or extremely firm. So if you had clay, that would be extremely firm. The sample can't be crushed with your fingers. Firm, the sample breaks when you apply a good amount of pressure and dents your fingers before it breaks. Friable, the sample breaks with a small amount of pressure. And loose, you have trouble picking it up, it will fall apart. Here's a picture demonstration of each of those terms. I suppose clay wouldn't be extremely firm. It would be in the firm category probably. And you've all had really hard compacted soil where you've had to use a hammer to break it up, and those different varieties. Soil structure. The shape that the soil takes based on its physical and chemical properties. Granular, blocky, platy, prismatic, or columnar. Without structure, single-grained or massive, like a big boulder. So here's a picture. Granular, blocky, prismatic, like a prism, or like a column. And then platy would be like a plate. Single grain, beach sand would be your single grain, no structure. It just falls apart. Solid mass with no shape, the stones. So here is a picture of these types. Granular, prismatic, columnar, block, and platy. Single grained and massive, like you have a big rock. Bulk density. It takes about 30 times driving over the same path with a vehicle to compact it to where plants cannot grow there anymore. That's not very much, considering like we mow our lawns, but we're not driving a car on our lawns. But if you drove a motorcycle over the same path over and over and over again, or a four-wheeler, it'll compact the soil, make it so dense that there will be no pore spaces for air or water. Prairie roads have this, and you'll see where the tire tracks are, no plants grow, but the weeds will grow in the middle where there is no compaction. So it's important that we don't compact our soil, because that is going to make it not have any spaces for water or oxygen. Bulk density and compaction zones. This is where we would be working the soil in a field, plowing it and tilling it, and this would be your compacted zone, and this would be your uncompacted subsoil. This is what happens. If you have pore spaces in here, this is where air and water would be. So the roots are going to be able to come through in here and set up shop and anchor themselves down, and water would be available to seep down into that soil and be available to those plants. So those are those terms. You can read those terms, and then let's go to the pictures here. So permanent wilting percentage, and then field capacity. What is available to the plants? When is it saturated? When is it available? And when are you going to be without that water in that soil where the plants will wilt? Each type has their different amounts of how much water can be held in the soil. The bigger particles will have more spaces between them available for water to be in there. At saturation meaning full, the pore spaces will have water and air filling those spaces. So you have these pore spaces. Here we have availability to have more water put in there. So we want some saturation, but we also need airspace. So too wet for plants is bad as well. If the soil is saturated, they won't have enough oxygen. At permanent wilt, there's no water available, so the plants will wilt. If you continue to have that no water in there, those pore spaces will collapse. In the dirty 30s, when the soil was blowing, that was because there was so little water, there was zero water, and had been in that zero water zone for so long that the soil actually collapsed, and then those particles became independent and didn't stick together. So in these next slides, you'll see some different compaction zones and how water moves around that. So there's an impermeable layer where water will no longer penetrate into the soil, and so therefore it starts moving horizontally. Different soil types, which like clay, does not allow water to pass through it. So once it hits a clay layer, it's going to go horizontally. If you're over sand, so this is all sand down here, water can penetrate sand. Soil sandwiches, wet and dry layers. So if you have wet and dry layers, it's going to change how the water penetrates the soil. And it's a hard thing, because you can have runoff and you can have erosion due to this wet and dry layers. Patchy soil moisture. Now these patchy soil moistures, sometimes if you have soil that won't drain as well, you'll get this patchy soil moisture. So there'll be patches of water in different places where the soil has stopped it. So you have these maybe clay patches that stop it. Sometimes when soil doesn't drain and you take a cross section of it, you'll see these gray mottled areas, and that is a sign of poorly drained soil. So if you have a soil profile and you see little mottled patches, that's what you're seeing is poorly drained soil. So summary, the rate at which water moves will be on pore space and the consistency, particle sizes, changes in water movement, so like how compacted it is, and may result in perched water tables creating an impermeable layer. Runoff, surface drainage, how steep the slopes are, the angle, soil or surface type, presence or absence of vegetation. It'll go faster if there's no plants on that slope, or slower if there are plants. And then dependent, if the plants have deep roots, they will hold that and allow it to infiltrate more. Total surface area of a drainage basin must include structural surface area. Structures modify soil saturation, contact areas, volume contact, and unit area. These are ways to control surface drainage, and you can pause the video and read through all of these. This is how you would stop soil drainage. Altering subsurface drainage. Again, stop the video and watch and read through these. Again, stop the video and read through these. You can read this one as well. Stop the video and read this one. So the soil horizons are always on there, determining where the soil horizon A, B, and C are. The top horizon would be the A horizon is your topsoil. And then your B horizon would be next, and then the C horizon. And then under that would be the bedrock. Now there are sometimes different layers, more layers, due to how the land was formed. So you can see profiles if you dig a hole or if you have a road cut through. Soil chemistry, chemical bonding, pH, nutrient availability, and cation exchange capacity. Now this is going to go through the basics of chemistry, so if you need a review, you can stop and read this. How we're going to study compounds are formed and broken apart in the soil and how these chemical reactions affect plants. So they're going to go through the basics of the atom. If you need to pause the video and read those, go ahead. Ions in the soil are going to help some things, water penetrate, nutrients be used by the plants, and absorbed by the plants. Sodium chloride is a really important ionic compound that will break apart into its anions, which are negative, cations, which are positive. Sodium chloride is important for soil as well. So here are some important anions and cations that are found in soil. Clay particles tend to have negative charges, which will repel water trying to penetrate into clay. So that's why if you put a drop of water on clay, it will kind of pool up on the surface, as well as the particles are so packed together. So like magnets, plus and minuses will attract, so will the ions, the plus and minus ions. Water ionizes, it will fall apart into its ions when it is in water, or it comes apart in the soil. It's called self-ionization, and only a small amount of it will do that. Now, pH is the amount of hydrogen ions from the solution that you have. You have acidity or alkalinity, which is a base of a solution. Here are some ranges of the pH scale. So now we apply that to our soils. Most desirable, most ag soils, extreme pH for mineral soils, You don't want to be in the extremes. You like to be in this range right here. But different plants like different pH ranges. And so they have those listed there as well. Take a look at those and see where they fit. Clay and organic particles will have negative charges. So soil reactions in neutral to high pH conditions. You'll see your calcium, magnesium, aluminum, and these are all nutrients that we need in our diet as well. And we're not going to get into a lot of detail, but you can see the ions that are necessary. Plants need nitrogen. They get it in the form of this nitrate ion, NO3 negative. Soil texture and physical nature of soil. Water availability, soil texture, bulk density, and this is the end of this presentation. That is, in a nutshell, everything you need to know about soil. But let me finish it up with one thing. The 4 major components of soil are whatever mineral component you have. So the 3 types of minerals would be sand, soil, silt. It's also made of air, which is about 25% of it, and about 25% is water. And then you have your organic material, which is also called humus. So you have sand, silt, or clay, which is your minerals, your mineral matter. Then you have air, water, and your humus, which is your organic. That's all the dead and decaying stuff that's in the soil. Remember, those 4 things make up soil. The end.